This is a Leupold Zero Point, and when you have it in the pouch, it's turned off, and then because the lip here on the pouch will push it up, and then when we push it down so it won't fit in the pouch, we see that there's a little light turns on inside. This magnet right here, very smooth. You have to wipe the dust off to get real accuracy. It's meant to be put on the end of a barrel, and there's a ruler built in the side. You can see here I put it on at 2 inches, which would be very common. 1.5 inch would be very common. 1 3/4 inch, and it's basically the distance between the center of the bore and the center of the rifle scope. Now, that's very useful for sighting in rifle scopes, wiping off the dust. But the little tiny batteries in here are a real problem to replace for me. And so I have removed the switch that's got the 2 batteries under it, and put on a different bracket on the back, and then I've made an LED and battery assembly that replaces it. The advantage being much easier to replace batteries, and batteries that last much longer. Okay, what is inside of a Leupold Zero Point? If we slide the switch off the end, we'll see that 2 batteries jump out and leap up on the magnet. And there are these tiny little magnets right here, and those are very hard to get back in. They also they don't hold much power or hold much energy, and so they don't last long. Here's going to be an attempt at putting the batteries back in. Now, if we see that there's a minus here and a plus here, that means that we want to have the batteries, well, they get zapped by the, in this configuration right like this, because this direction is going to go on, is going to push it in this direction, and when it goes in the sheath, it'll be pulled back this way to turn it off before it goes in the sheath. So we basically want to get it in there, and then that on there. So we try to put these in here. We got one on. Now that's upside down. Okay, we managed to get the batteries in the correct configuration. We got the positive on this end and we got the negative on this end. And now we're going to try to slide this assembly here into this space somehow without those batteries jumping up. And the best that I found is if I hold the batteries down with one finger and then try to use this bevel. That one jumped out already. Get back in there. Nope, can't get them in there. There's one in place. This is pretty frustrating. I give up. As an experiment, I took an LED, which you'd have like on a keychain, and attached some pipe cleaners to it, and then a washer to act as a magnet, and then simply slid it on as so, and that acts in kind of a Mickey Mouse way as an experiment, and it proved viable. This is what it looked like when I put the keychain white LED on. piece of aluminum. If we want to turn one of these into one of these, we're going to have to make a drawing. So a drawing would look something like see that? So, in order to make that happen, we're going to have to make a drawing that tells us how to mark this up. So, the distance to the center here is, we measure this at about 785. So we take 785 and divide it by 2. 785 divided by 2 is equal to 392. So what we want is, we're going to want a line that's going to be at 392. And then we do the same thing from top to bottom. And this one is 1462. We divide 1462 we get 731. So we want to go up this way. 731, we're going to make a line, and then we're going to have to make a line down the edge as well. And the thickness that we get here is 375. So we divide 375 by 2. 375 divided by 2 is equal to 187. So we make a line right here at 187. Also, going up, we want to make this at 0.2 and this at 0.4. So we're going to have two more lines that are going to come across here. And that will be at 0.2 and 0.4. And then our how deep we're going to make our cut up the center. It appears that we leave about 0.325 behind for the LED. So if I go 1.462, is that what it was? Minus 0.325. It's 1.37, so that would be another one up here. 1.137. So we want a line at 0.392. So we dial in 0.392. And we tip over our part here, and we go in with the stylus on the height gauge. We draw that in, and we like it all the way around. And we want another line at 0.187 on the sides. So we go over here and we just dial in 0.187, as so, and then we we scribe around our part through the die cam, and that'll show us where to drill our hole on top where the LED goes through that hole. The other holes the other lines that we want are at we want at 0.2, 0.4. So I'm going here to 0.2, and we like that to be nice and accurate because that's what's going to clamp onto the Leupold Zero Point. And we want 0.4, and the distance between those two is going to give us the 0.2, which is going to be the clamps onto a ridge that they provided. Okay, we're going to drill our centering hole for our LED. Might be difficult to see. I'm just going to come over here and get really down over there. Well, that's certainly deep enough for any LEDs we have. Okay, we're going to clean off the chips with a vacuum. Okay, we use parallel bars to get the right height of our part in the vise. So we take the parallel bars out then, because we're going to mill through them. First we're going to put in a wiggler, and the wiggler is going to tell us when we're centered up. Okay, we have a wiggler in. And we have to steady the wiggler first. And once we've steadied it, it'll tell us pretty much where the true center is. Here we can see that when we turn the wiggler on, we've got it centered up. It's right over top of the line where we want it. Now we're going to mill out some material. Give you another look. See down there? right about on the line. Now when we take our part out, we've made this cut right up the middle. Can you see that cut? I have to file that to get these little burrs off. Okay, I'm going to file little burrs off. So we might be able to do this with a deburring tool. You can get done really fast with a deburring tool, probably. Yeah, it is fast. Still have to do some file work. There's no getting around it. You know you're done when it stops cutting your fingers. Okay. You got to run the vacuum cleaner. This mill cleaned out so everything sits nice and square and flush. Okay, if you're paying attention, we've recovered the existing part from the vacuum cleaner. Okay, we've got a 374 gauge pin in a collet in the mill, and that should allow us to center up, because we want to make another cut. Okay, we're just about centered up, and then we lock in place on the horizontal. And then we remove that pin, and this is just a pin gauge that's 0.374 in diameter. We're going through the work and making a T-shaped slot, and once that's fairly well cut, then we can adjust up or down to the lines that we marked on the height gauge. You got the Now, already the hacksaw right here and here, so there's to be some slots that can bend. This is .2, this pin gauge, which is what we want. That pin gauge doesn't fit in these slots yet. So what we do is we just take and go in there and file the slots until we can get a .2 pin gauge in there. That goes. That goes. That goes. And that goes in. They're tight. See if we can tip this thing 15 degrees. That's 15 degrees right there. Now what we want to do is put this bevel in about halfway down. So we set the machine at 15 degrees. Now we're going to spin it around, lock it up. That should work. And there we've knocked about half the die cam off the inside, so we know we've got about the bevel goes in about the right distance. Deburr everything. Looks like it's ready to go. And this mess of wires has got the LED hooked up to a power supply, and we're measuring the current that's going into it. It's a variable bench power supply, this one over here. And what we're measuring at 30 milliamps, which is the absolute max rating for this LED, is that we've got about 2.257 volts that are across that. So we're going to use that to then calculate what ballast resistor to put in series with our battery pack. Here we have a voltmeter and a battery pack, and we've got two fresh batteries. We're going to measure and see how much voltage we get from a fresh pair of batteries. Looks like we get 3.226 with brand new batteries with no load. Okay, now that we know that we've got 3.226 maximum coming out of this battery, I've drawn a schematic here of what we've got, and that is we have 3.226 volts coming out of the battery from ground, coming out of the battery, and we know that we want about 2.257 volts across the diode in order to get the 30 milliamps, which is its absolute maximum rating. So then we can write an equation. We can basically say that R is equal to V1 minus V2 divided by the current, which would be 3.226 minus 2.257, all divided by 0.03. So I can do this. 3.226 minus 2.257 equals, divided by 0.03 equals, and that's R is equal to 32.3 ohms. Now, if we want the current to be always less than 30 milliamps, so we never stress out the diode, we want to make it slightly larger than this. But I happen to know that I've run one of these diodes all night at 95 milliohms and it didn't blow up or burn up. So we just want to get anything close to this 32.3. Okay, now we're going to solder this up. We want the resistor to be in series with this. We want to have some heat shrink sleeving over top of the joints. So cut off some heat shrink sleeving. We put that on the wires ahead of time. Then we take the long wire, the long lead coming out of the LED, which I found to be where I want the high voltage to go in. We're going to make a junction with our resistor. This is our 27 ohm resistor that we've played with before. And I'm putting bends in the resistor so I can make connections. I can put a bend in the wire. So we have to make a mechanical connection before we can make a solder connection. Okay, we've connected the resistor to the battery pack. Okay, now we've connected the diode to the resistor. And we'd like these to be the same length. So we're going to try to bend the diode lead to make these all the same length. Let's put it up there. Okay, now we have our electrical connections. We could put a battery in here and make sure the diode turns on. And it looks like it's turning on. So we can trim off that's our switch is pulling that battery out. Trim off these leads. Don't need them sticking way out of the solder connections. And then we can pull the heat shrink sleeving up over top. And you can turn on a heat gun, and the shrink sleeving should shrink. Okay, these two batteries, which didn't have enough left in them to turn on this camera, these two old AA batteries, have been running this LED for 3 days and 3 nights through the 27 ohm resistor, and it's still plenty bright enough to work in the Leupold Zero Point. So I guess there's a place for old shot batteries in this. This is a drawing. If you want to make one, you could push pause, print screen, paint, paste, save as, save it to your desktop, and then open it up and print it, and then you'd have a drawing.